In this video we're going to look at another example. Now this is working out the greatest common divisor of two numbers using a subtraction method. Now maybe not the most exciting thing, but it's a nice little bit of code and you can always have a read through this and read through the code and see how it works, and it helps you to build up your understanding of the assembly language for your CPU. Now the greatest common divisor is just the largest number that divides two other numbers, so for example the number 18 and the number the number 12. So 12 and 18, so the greatest common divisor, the largest number that goes into both of those. So 6 will go into 12 and 6 will go into 18, okay? So that's the largest number that will divide both of them. So we just work through an algorithm. So the algorithm's here. I'm not too keen on just reading over it, so you can read over the algorithm yourself, okay, at your leisure. And I'm going to use two numbers in order to show you this working. But again, the code's set up so you can put in other numbers quite easily. So the numbers are going to be 36 and 84. Now it turns out that the greatest common divisor for 36 and 84 is the number 12. So 12 actually in hex is 0C, so the final answer is just going to be C. So let's have a look at the code. And again, I'm not going to go through the details of the code, but we can have a look yourself and you can read through it. We're really just interested in the nomenclature and just the constructs that we have within our assembly language. That's what we really want to learn at this moment. And then we'll put it into the CPU and we'll see it working. So let's have a look at the code here. If I can find, so this is the code here, and a little bit longer than other bits of code, but it starts off the same. We've got our origin. You can see this at this side. Bring it in, yeah. So we've got the origin, so the start of our program here, and then we've got the program, and you can see it's broken into our little loop. So there's a start loop, there's a done loop, there's another one here just called loop, there's a swap and a subtract and an end. And down at the bottom here, we're going to have our other directives. So the start address for our data is going to be 0x8020, and we've got our directives here. So we've got our DS1, so our result's going to sit in this location 8020, and we've got the EQU, so equals 1, EQU 2. So num1 and num2, so this is where we put our two numbers in. Now remember, we're doing it in hex, okay? So the numbers are 0x24 and 0x54. Now we could actually, rather than put them in hex, we could put these numbers in here if we wanted to. We can just put the actual numbers in. So that'd be the smaller number, so that would be 36. And we could put in this number here, which would be 84. Okay, so we could actually put the numbers in here just in normal decimal numbers, and it'll do the conversion for us, and it'll work through the conversion. So we'll go in here and we'll go into File and we'll save this, and then we can run through our assembly language. So our assembler, simulate. Okay, so that's it ran through our assembler. We could then again and have a little look at the pass 1. So I'll bring it out here so you can have a little look at it. So that's the pass 1 here. And you can see here that it's taken the numbers 36 and 54. I'm not sure why it puts these little spaces. I'll have a look at the assembler and just fix that, okay? So we've got our 36 and our 84. I'm not going to talk our way through this. You can have a little look at this code, and you can have a look at the original assembly language code, and you can have a look at the algorithm, and you can see how it works through each of the lines. It gets a bit boring if I just sit here and continually talk through little algorithms like this. The videos go on for hours and hours and hours. Okay, so having done that, what we want to do is load the code up into the CPU. So we'll bring up the CPU and we'll get our code loaded up and in. Okay, so here's our CPU here, and we'll reset it, and we'll fix it up so you can actually see it properly. Okay. Right, now we'll reset the CPU. And we'll load up the code. And again, you should go ahead and download the program which is in the resources section, and you can work along with me. Close window, and then we're ready to run this up. And I'll just let it run itself. It should be relatively quick. Simulate and tick enabled. The 24 and the 54 you can see here, and this is it working through the algorithm to work out the final value. Now when it gets the final value, we're going to have the little red light. So that's the little red light come on, and you can see that the final value for it is 000C, which is the number 12. Okay, so if we go simulate and we stop the simulation and we kick into the here, and you can see that at position, it's quite small, but you can just about see it. At position, that's 8020, we have the answer, which is the value C, which is 12. So we can see that the first couple of lines here, those are the position of the program, and from 8020, that's the position of the data. In this case, the data is just the result C. So again, you can go in to your assembly language code and you can change these numbers to different values and test it out. So that's another little example that we've worked through, and let's have a look quickly just to see if there's any unusual commands. So the commands are the data, there's a jump to look, there's a store, another jump, and then there's the compare, jump if equal, there's compare, jump if A is greater to the subtract algorithm, there's a swap, there's the exchange register. This is a subtraction algorithm, and we've seen at the bottom we've got our directives. So there's nothing new in the code here. So we haven't really built through a lot of code that has our fancy addressing modes, so we won't get to that kind of code until later on, okay? Or possibly we might take it into the next course. So that's all for this video. Thank you for listening. I'll get you in the next video. Goodbye.